Section 5.4 is on solving compound inequalities. A compound inequality is two inequalities that are joined by the word and or by the word or. Let's take a look first at and inequalities. These are true only if both inequalities are true. When it's graphed, it is the intersection or the overlap of the two graphs. Let's take a look at a couple examples here. So solve and graph. X minus 3 is greater than or equal to negative 11, and x minus 3 is less than or equal to negative 8. Let's solve each part separately. So I'll add 3 and add 3. So x is greater than or equal to negative 8, and adding 3, x is less than or equal to negative 5. So both of those conditions have to be true. So let's see what that would look like on a graph here. So let's do a little number line. I'll do negative 8 and negative 5. Don't really need to put the numbers in between. So the first part says x is greater than or equal to negative 8. So that would look something like this. Okay, that's my first one. Second one, x is less than or equal to negative 5. That would look like this. So I need the numbers that satisfy both of those conditions. I need the numbers that are both greater than or equal to negative 8 and the numbers that are less than or equal to negative 5. So that's going to be just this region in here, just where the two lines overlap. So my final graph is going to look something like this. I have a negative 8 and a negative 5 and a solid dot over each since those are or equal to's, and a line between them. So it kind of looks a little bit like a barbell. That's what the graph would look like. Now another way that you can actually write this inequality, I can write it x is greater than or equal to negative 5 and x is less than or equal to negative 5. If I were to take this first one, let's see, which way do I want? Yeah, this first one here, I'll move him over here, and flip him around. So negative 8 is less than or equal to x. Notice that means the same thing. It's opening up to the x and it's pointing at the negative 8. And then I just kind of put these next to each other, put them, kind of combine them together. I can write it as negative 8 is less than or equal to x, which is less than or equal to negative 5. That means exactly the same thing because both of those conditions are being met there. And I kind of like writing it this way because it kind of looks like the graph. X is in between negative 8 and negative 5. X, which is represented by this line, is all the numbers that are in between and including negative 8 and negative 5. And in fact, here's an and inequality that's already written that way that we need to solve. 6 is less than or equal to x plus 7, which is less than 10. The goal here is to get x all by itself right here in the middle. So notice it's having 7 added to it, so I need to subtract 7 from that. But I need to subtract 7 from each part. So that's going to be negative 1 is less than or equal to x, which is less than 3. Now when I go to graph that, I'll put those two key numbers on my number line, negative 1 and 3. And since this is a less than or equal to, I'll have a solid dot over the 1. Since that's a less than, it'll be an open circle over the 3. And x is in between them, so we draw the line in between. So that's what an and inequality looks like. The other type of inequality is an or inequality, and these are true if at least one of the inequalities are true. It's actually the union or everything of the two graphs. So we're going to combine both of the graphs and take everything that's covered by that. Let's take a look at a couple examples here. So solve and graph. X plus 1 is less than 4, or x minus 1 is greater than or equal to 3. So let's solve each one of those separately. So x is less than 3, or, and let's add 1 here, x is greater than or equal to 4. Very important, you must have the word or in there. Okay, now when we go to graph this, I'll put those two numbers on there. I'll have a 3 and a 4. The first part, x is less than 3, is going to look like that. The second part, x is greater than or equal to a positive 4, looks like that. And because it's the union of the two graphs, I'm not looking for overlap. I leave it just like that. Most of the time, an OR graph is going to look like that with an arrow going in each direction. It's either less than 3 or greater than or equal to 4. And let's take a look at one more example here. X plus 2 is less than or equal to 11, or 4x plus 2 is less than 10. So let's go ahead and solve each piece. So x is less than or equal to 9, or subtracting 2, 4x is less than 8, divided by 4, x is less than 2. Now this one's a little unique because notice both of these symbols are less thans. So let's see what this looks like when I graph it. So I'm going to have a 2 and a 9. My first one says x is less than or equal to 9, which is that piece there. My second one says x is less than 2. Okay. Now remember, since this is an OR, I want to keep everything. So what is the union of those two graphs? And actually, my final graph should look like this. I'm not looking for the overlap. I'm looking for like everything all together is just going to look like this. So the solution to that compound inequality is basically just x is less than or equal to 9, because the x is less than 2 is actually contained in that. So in this section, we took a look at solving compound inequalities, and inequalities, and OR inequalities, and what most of the time the graphs of those